So you bought an old jet and you're wondering how the heck do I make this thing airworthy? Well, you've come to the right place. Video number 2 in the Super Bandit Revival video series. Video number 1, we tore this thing apart, did a whole bunch of restoration and fixing and updating to it. Let's dive back in to this aircraft. All right guys, so previous video, we kind of just finished up putting the back end together. All those surfaces, pipe, turkey feathers, tail cone section are all installed and the plane is looking lovely. We did get the nose section painted black. We're gonna do some clear coat over top of it, but we're gonna let that cure for a couple days, but this is going well. Just painted the top of the bypass. That's primer coat. It's gonna be painted red to match the other red accents, so working on that. And we kind of wrapped up with putting new heat shield on the hot section of the bypass. So that is progress so far. Next thing we're gonna do is get our bypass painted red. All right, we're also working on the air brake right now as well too. So this mounts on the belly of the aircraft. We've put our new servo here. I'm gonna get this plugged into the receiver to get it positioned and centered and everything. The air brake, because this is already just a refit, everything's pretty straightforward and set up. The servo arm's a little bit longer than the one that was previously installed in here, but it'll actually work better because it'll give us more air brake and it will allow this to be mechanically locked when it is all set up. So we're gonna get this servo plugged in, programmed, installed. All right, so we got 2 coats of red paint on our bypass cover. That looks awesome. Very, very nice red. Same paint that we used on all the trays on the inside. Next thing we're gonna do is work on getting our pitot tube mounted. So we use a Jetty M-Speed sensor. This is kind of our regular process for this type of thing. So the M-Speed sensor, the 450EX model. And we're gonna mount it exactly the same as we did, like you can see on the Picaro here. So the Picaro is a plane from Elite Aerosports that we recently did. And it might be hard to see, but there is a pitot tube mounted in that nose. So we only have just the tip of it sticking out. And we're gonna do the same thing on this plane. So what I do is I drill a 1/16 hole and just keep going up in size, making sure that my drill bit is level up and down and straight side to side. That's kind of an important thing. So we're gonna get that drilled out and get our tube mounted. Once the tube's mounted in the nose, then we can get our air tank mounted in the nose. We need to get that stuff done as we kind of work towards the equipment stuff. We need to get the back end done as we start to work towards the equipment stuff. All right, we got our air brake set up here. I know we said we were working on the pitot tube. We will get there, but air brake is all good. So when it's fully down, you can see that it mechanically locks, which is great because that means that all the force is being taken by the servo shaft, not the servo motor. And then that is the up position. So that's pretty straightforward. Did have to space it out a little bit with some wood spacers to get it in line like the previous servo. And that's one of the things you'll find with a kit refit like this is you do have to do some adjustments and modifications, especially if it's an older kit. You know, our servos have gotten different in size, the servo arms and everything will change. And with that being said, I'll show you another thing that we need to take care of here with fitting a servo in. So I'm just getting all of our trays and stuff kind of sorted out as much as I can. I got my UAT mount mounted on our board here. I think the last Super Bandit, I just zip tied it to the actual board itself. That's a bit of a challenge sometimes to get the zip ties behind, and that's why I'm using one of our flat 3D printed mounts. So that's high solid in place. I've just got it spot glued with some CA just to keep it stuck. And then just looking at the steering servo here, so I had to open up the opening a little bit, which was fine, but this steering servo isn't going down all the way because we have our brace down here, which is the mounting point for our door hinges that is sitting too high. So we need to take all of this stuff out and do a little bit of sanding to that brace so the servo can drop all the way down. Now I could space the servo up. The downside is then the steering arm is possibly not going nice and straight. So I want to get that servo mounted down all the way. All right, so we finally got our pitot tube hole done up here, so we're going to get that spot glued in with some CA, and then we'll put some different adhesive from the backside to hold it more firmly, so we'll work on that. Also getting ready to paint the tank. So we're going to switch the vent fitting out on the hopper tank. Now the hopper tank is kind of the critical one. The other two tanks, because they just go to the vents, not so important. So we're going to eliminate the single fitting and we're going to go with a double fitting. Now that is kind of the style that has been, I guess, adopted on the newer Super Bandits. That's what we did on the previous red ones. So we'll switch that out for two vent fittings, 90-degree vent fittings, and that'll work good. Also last night, while we had some epoxy mixed up, we glued the washers to our wing bolts, so those are all done as well. Just little baby steps, all the little details. All right, so we got all of our tanks painted, the main tanks there. Nothing changed on the main tanks. We just obviously redid the clunk line, so that's changed, but the rest of it's all stock. The front tank here is all painted as well. We've got our new twin vents on there, which is awesome, and then a little spot there for checking fuel level in this tank. And then we, of course, changed the clunk lines as well. So now we're getting into the finer details of the aircraft, which means figuring out where all of the stuff goes in the aircraft. So we've got the pitot tube mounted here. You can see it, just the little tip of it sticking out, and have been playing around with setup here. So SPEC 30 is now going to go here. That's going to work out well. M-speed sensor is going in the front here. I think our brake valve is also going in the front here. And turbine data relay module, which is the ECU, I guess, a lot of people call it that, is going to go on the bottom portion here. And then our Cortex primary receivers going on the top. Fuel pump, I think we're going to put it right there. We kind of talked about that in the previous video. And then we've got our other air equipment, which is getting laid out here. So I've kind of been working on this stuff while we painted the tanks. Can't get the turbine mounted until the tanks go in. So there's just that whole system of everything. So what I'm doing now is I'm getting everything set up with the sequencer. So I just got the sequencer plugged in, going through with the terminal here, just getting everything set up. And next thing I'm doing is the programming of the valves. So the way this plane works is doors open, gear comes down, doors close. When you do the gear up cycle, doors open, gear comes up, doors close. So there's a bit of a funky programming. Really, it's not that complicated, but we're going to get that stuff done next. All right, so main fuel tanks have dried enough that we can install them. They're 100% dry, basically. So one thing that's important when you're doing saddle tanks like this is if you've got to pre-install your fuel line, you want to cut them the same length. So the two vents that we've got here are exactly the same length. The two fuel pickups are exactly the same length to each other. And then when we get these installed, if we need to cut 3 inches off the vent lines to make everything work, then all we have to do is cut the exact same amount off each vent line, and we know that the lines will remain the same. They've all been safety wired as well too. The air brake does need to come out, or sort of needs to come out for those fuel tanks to go in. It's a pretty tight fit, but we're going to slip those fuel tanks in there next. Getting those fuel tanks in is a big step for getting the rest of our stuff moving forward. Time to work on the bypass and getting that all fit. So I have been working on this a little bit, and we have got the engine all sorted out. Now, one of the things with these BVM bypasses, obviously you're using the tabs that come with them. And one of the other kind of tricks I've learned here from doing a few of these kits is in transport, sometimes those engines can shift down. So what I do is, this is the top of the turbine. I make a little bracket down here. So this bracket actually sits against the bottom of the bypass, and in transport prevents this from dropping. And that's something you always check on these BVM kits. You always, before you fly them, you look up the tailpipe just to confirm that it's centered. But this is very helpful. As far as size goes, you kind of just have to guess. I got the turbine mounted in the bypass, took my pinky, kind of jammed my pinky underneath there, and I was like, well, my pinky's tight, so it's a little bit skinnier than my pinky, which you can see there. Very technical. And this is just a piece of aluminum that we've bent to go between the straps. So you can see there, that bracket is right on the bottom of the turbine. So this is all perfectly positioned now in the bypass. Now I'm not sure if I want to put the bypass in yet because I want to get my lines run from the back end. So our rudder line and our 2 elevator lines, which are going to come up and then go forward. So I'm probably going to pull this bypass out again now that I'm happy with everything and get those lines run next. The other thing, because this turbine's sitting forward so much, like the tail cone is kind of right here, I want to get the top part of the cover also heat shielded as well too. So I'm going to sand that down first, just this portion right here, and basically paint the exposed section that's going to sit here with heat shield. All right, little progress updates. We've got our hatch cover or bypass cover ceramic paint done. Engines installed, bypasses installed, lines are run forward, tanks are installed, lots is done. So one of the things with this Super Bandit is the tanks kind of need to be spread out to avoid any contact with the air brake. The air brake's on the underside right in the center. You can't really let the tanks float around. If you do, the air brake's going to contact, and it's just not a good situation. So a little hard to show you now because the plane's right side up, but I do have some foam jammed in there. The foam is accessible from the underside. That foam is just temporary. I will take that out, but what I've done is I've put a glob of silicone in between the front part of the intakes and the tank. So once that's cured, it'll take a couple days. We'll pop those foams out. I mean, the foam can stay, not really a big deal, but you know, better if it's out. So just been working on running things up front. So we've got our lines run up front. We've got them covered in snakeskin when they go beside the tanks. We've got our data relay module installed and figured out. So just slowly going through the process and trying to get things organized. And a few hours later, we've got all of our servo leads and airlines and everything run. So I'll take you guys through this. We've got our door valve right there. Our gear valve is right there. All of our airline stuff is run down to this location. So everything's teed off. And these are all of our airlines, these 5 that run to the wing. So they're all sized long enough right now to get bundled together and come right underneath the turbine and get mounted to the underside of the bypass. So that's done. So these leads here are the same thing. So they all go back to connectors to plug the wings in. So this is all like the wing connector stuff. All of our other servo leads are all run to this area right here. So the intention of running all these things is they're all sized just perfectly for our top plate, which is our cortex and primary receiver. So those are all going to come behind the plate right there and plug into their respective locations. So they're all sized just enough. We've got our telemetry expander here, our E4 expander. We only are using 2 of the ports. So the way this works is we've got our SPEC 30 down here. The SPEC 30 in the first port has our M-speed sensor, which is right down there. And the second port comes over here to our expander. That expander is going to mount on the underside of that top tray. And then in our expander, we've got our Chikoi sequencer fail-safe telemetry and our Chikoi turbine telemetry plugged into there. So that is all of our stuff. Our brake valves up front here. Everything's a real mess right now, but it will get cleaned up. The intention with everything that was going on here was to get everything run, labeled, ready to go. Next thing to do is get our top tray right here plugged in. And the other thing to do when we get our front tray is here's our main battery connection. So this is going to get screwed down to that front tray. And then if we ever want to take the front tray out, this can get just unscrewed. We will probably have in this front tray, we're going to have our fill valve and our gauge for our air system, probably skewed towards the front of the tray. And the reason we would skew that towards the front of the tray is to keep it away from the gear. So all of this stuff is going to be tied to that keeper right there. Our air system tie-in needs to be added here, but we want that stuff to be tucked in the front so it doesn't interfere with our landing gear. Whew, that's a lot of stuff. So we're going to get our front our top tray installed and plug everything in, and we want to confirm that we're happy with everything. Before we do that though, I'm going to get our receiver and Cortex set up. Now I have done videos on the different Cortex setups with Jetty. So number 1 is with a central box, number 2 is with this situation. So if you check the videos, there is a setup video on that, and I'll try and remember to put a link down below in the video description if you're curious on how this works. So we are using 1 battery on this aircraft. So what happens is the 3-cell LiPo plugs into that red connector in the front. That splits off. One set of leads goes to the SPEC 30, the other set of leads goes directly to the turbine, and that 1 battery is going to power the entire plane. As we said in video number 1, many of you guys don't agree with that, and that's okay. This isn't your plane, so it really doesn't matter. But let's get that top tray installed. All right, so we just finished our live, and we've got some great progress on this aircraft. So we have pretty much wrapped up the entire front end here. Our front tray's installed. We've got our battery plug-in done, our gauge, our air fill, and things are looking very nice. One thing I'm going to do next is I'm going to get the aircraft on our Lukey stand flipped over and deal with our lines coming to the wing connections. Now the point of doing that is I want to get everything mechanically done and set up before we finish off the fuel system, because as soon as we put that fuel system, mainly the front hopper tank, inside the aircraft, that blocks all of our access to all of our air valves, and it's nice to be able to make sure that the air system works 100% before you button everything up and hide everything. So we do have all of our servo stuff all plugged in. Everything's working so far, other than we haven't plugged the wings in yet, but things are looking very good. So we're gonna get the plane again flipped over on the Lukey stand and get our center section things figured out. All right, so we've got the plane upside down, wings are installed, and working on our leads. Now, one of the things with the leads here is we basically want to make all of our connections inside the fuselage. So when you're putting this plane together, this is exactly the process. You take this bottom hatch off, you get the wings installed, your fasteners are all kind of internal, and you're sticking your tool through the little slots here and getting the 2 that are at the root of the wing, which is right there. So anyways, wings are installed. So we want to have all the fasteners coming to kind of that, or all the joints and everything coming to that point. And that's why we left these guys here, which are our airlines for our wings, to come to that point. So our airlines are going to come like this. They're going to tee off, and then we're going to have our connections just like that. So should work out well. Previously, when we were working on the wings, I did go through and do a bunch of yellow paint chip touch-ups. So there was just little chips everywhere, like around the openings here, you know, little spots like that. And I had a yellow that was very close, so went through and did all those touch-ups. We still have a bunch of black touch-ups to do. You can see the black in, you know, areas like this as an example. So we'll just go through and just touch those guys up in black. But yeah, the point of the purpose right now is to get these connectors done. So our ash lock connectors, easy peasy, we've got those. Our airline connectors, not so much. I did use shoe goop and glue down one of our little keepers right there. This is the zip tie style keeper. So all of our leads, there's also another one mounted on the other underside of the intake, which is right directly below my finger. So those have all been zip tied to that guy right there. And that's to keep it away from the servo for the air brake. And then we'll have the same bundle coming to that one right there. So everything's clear of the air brake. That's a critical thing. Previously on this plane, you know, some of the air leads and stuff were just run right over top of all this stuff and just dangling. So you want to be careful with that type of stuff. All right, so we got all of our leads and everything done up here. Tried to make this as neat as possible. Now initially I was going to make these very short and just long enough to connect, but I left them longer, and the reason for that is this is just so much easier to connect. These leads together like this. So I think that's probably how I'm going to keep them. I had one set of the twist lock ones that we're using. These ones we're waiting for from DreamWorks. So in the meantime, I used some Festo fittings. They're not the exact right size for the airlines, but I think they'll work for testing purposes. So that's good. I think what we're going to do now is flip the plane back over, and we are going to pressurize this thing, turn it on, and see how the gear works. Hopefully, if all these fittings hold pressure, that's really the key right now, because again, the Festo fittings are not the correct size for this tubing. All right, guys, so we got the everything aired up, and the gear works good. I will show you that once we figure out the air leak. That brings up our air leak. So when I fill this plane up, it loses about 1 to 2 psi every 1 to 2 minutes kind of thing. So it's a very slow air leak, and I'm just kind of going through the process here. So if you've been following along with this, the air tank is here. We've got the air tank coming out, obviously going to our fill lines and gauge, and then also teed off there, it goes to our brake valve. That airline comes back, tees to our sequencer failsafe, comes back, feeds our door and gear valves. So what I did was, with the plane turned on, I clamped off our line feeding our door and brake valves. That didn't change anything, it continued to leak. Now our PSI is getting fed from the Chikoi sequencer failsafe, so reached in there, squeezed that guy off. Now as soon as I squeeze that off, what I'm doing is I'm isolating the pressure in the failsafe sequencer. Then it stayed consistent. There was no pressure drop. So basically our pressure drop is happening somewhere in this front section. All right, got a phone call. So to continue on, so I've kind of isolated this from the failsafe sequencer forward. So what we'll do now is, the other thing I noticed is when this plane is off, so power's off right now, we do slowly lose pressure. So that front valve here for the brakes is suspect. I think that's probably our issue, but we're gonna dig into it and find out. So what I'm gonna do now is I'm gonna pull the front tray out, and that will allow us to clamp off the brake valve with the power on, with the power off, and find out if that Jetronic low loss brake valve is our culprit. All right, through process of elimination, finally figured out the tank is leaking. I've actually never had an air tank leak before, so but that's what it is. What I ended up doing here was turning the system on, clamping off the brake valve. I thought it was the brake valve, clamped off the brake valve, didn't leak. Clamped off this valve going to our fill and gauge, didn't leak. Clamped off the brake valve, stopped leaking. As soon as I opened this up after about 10 minutes, obviously the pressure in the system dropped because this was substantially lower. So it's the tank. Very curious. Again, never had that happen before, but we'll switch that out. All right, so we've got all that problem solved. Actually, I put another air tank in there, a Robart one, and it was leaking as well. Then I put another tank in here. I think it was the original one that I took out of here. So it's a BVM one or whatever. But anyways, that's all back together, all solved, all good. Filled that up, confirmed that it was holding pressure. And then now I've powered everything up, and we've been sitting here at 65, 66 PSI consistently, and everything is happy. One thing I've noticed with this plane is if we go to 100 PSI and do gear up, the valve actually leaks a decent amount of air, and this plane operates better at like 80 PSI, so the gear still works down to like almost nothing. All right, so I've left the airplane on for 15 minutes, gear in the up position, and it stayed at 65 perfectly. Now we've got the gear in the down position, and we're gonna leave it sitting for a while, but I will show you guys what this gear looks like. So it operates beautifully at a nice low pressure. So we're sitting at 53 PSI. You can see right on the top right-hand side of my screen. We'll do gear up, doors open, gear comes up, doors close, and we are now at 43 PSI. So that's about 10 PSI per gear cycle. And now we'll go gear down. 36 PSI, so really uses such little amount of air. Oh, there we go, doors closed, 34 PSI, so about 10 PSI per gear cycle. But we're at 34 right now. We'll do gear up again. Still works beautifully. Doors close, gear down. 24 PSI, 21 PSI. It'll drop below 20 when the gear doors close. Oh, there we go, 21 PSI. Gear up, let's see. Oh, no, so about 20 PSI is the cutoff. So the reason to do that is that gives us an idea of where to set the fail-safe. So the one downside is if you let the gear system get too low, you're not going to have brakes. So that's kind of one of the downsides, but this gear operates so nicely. So what we'll probably do is we're going to put a label on the fill valve to put 80 PSI as the max. You take off gear up, you're going to drop to 70-ish PSI for gear up. Gear down, you're going to be at 60 PSI. And then what we'll do is we'll probably set the fail-safe at about 45 PSI, I think, because it operates beautifully. Maybe we'll do 50 PSI for the cutoff, and that'll work well for this aircraft. That's done through the Chikoi Air fail-safe sequencer. All right, so we've got our little data thing plugged in here to the sequencer, and we've got the fail-safe set to 50 PSI. So moving on to, now that our air system is dealt with, we can move on to the fueling system. So like I mentioned previously, this is what I was waiting for, and waiting to get this 100% complete before we started on the fuel system. I just put the tank in place, so that tank is there. We're not gonna have to take that out again. And we've got all of our lines for our fueling system pre-run. So first thing I'm gonna do is I'm gonna get some snake skin installed on our turbine lead. So I'm going to basically run that from the end of the turbine lead to about here, and then we're going to have the excess will just be jammed beside the tank, and then this comes through our slot and our bypass right there. So obviously we want to protect this wire from rubbing on anything, and we're going to put a little bit of spiral wrap around our fuel lead here, just maybe an inch, just to protect that fuel lead as it goes through the carbon bypass. So those are all the little things that you want to be taking care of. All right, well, I was racking my brain on where to put our fill line. So what I ended up doing was running the fill line back here. And we've got our little pocket thing that we, the drip catcher that we install in there. We've got our Festo setup, which is a 6mm valve, and the little quick coupling end. So yeah, I was absolutely, and I was going to put it down here. Problem with putting it down there is if you want to change like the O-rings holding the front tank in, you really need access to that area. So anywhere I put it here, I was really restricting access to anything in the future, which I'm trying not to do. So fuel system, done. So if we trace this fuel system, we put fuel through our filler. That goes in this fitting right here. Fills up the UAT, comes out through here, goes into the hopper pickup, fills up the hopper, comes out the vents, goes into the saddle tanks in both of the pickup lines, fills up the saddle tanks, comes out the vent, vent comes forward, and goes out of the plane right underneath there. So that is the fuel path for this aircraft. I think we're ready to fill this thing up and run it. All right, so what we want to do now is we want to fill up the fuel system. Now, one of the reasons to fill up the fuel system is with the UATs that have a fabric filter in them. So the MAP tanks have a fabric filter, or looks like an oil filter kind of thing. You want to always have fuel in the UAT. So what happens is when we first fill this up, there's a lot of air trapped in there, and we'll get the fuel system primed up, but what will happen on the first run is all those air bubbles will get sucked out. and then we'll always keep this thing full. So we want to get the fuel system full for that reason, but we also want to check the volume of the fuel system. So we're going to be using our pump here from RC Custom 3D Printing, and that'll tell us how much fuel volume goes in here, and then we can program that into the telemetry for the Chicoy turbine. So we've got the fuel readout on the programming for the aircraft. So we're going to get those things filled up and check and see how much fuel this thing holds. All right, so we've got the fuel system filled, and I'll show you guys the volumes here. So normal Super Bandit, we are 3.5 liters. So our setup here, I mean, obviously varies a little bit, but front tank is 1 liter, each saddle is 1.2, so about 3.4 liters, which is perfection. So that's good. We've drained a little bit of the fuel out of there so we could disconnect our taxi tank, and we are ready to run this thing. But I'm gonna snake you guys, and we are going to wait till the next video to run that aircraft. So we still have a lot of things to wrap up. So because of that, we are going to do the test run in the next video, along with finishing up the final bits and bytes. So thank you to you guys who entered the fuel jug giveaway. So thank you RC Custom 3D Printing for providing the fuel jug. Very, very nice, and congratulations to whoever won it. I don't know who won it because I haven't done the draw yet. I'm just recording the ending of this video, but congratulations to whoever won it. It will be inserted at some point in this video. So we're gonna pick a winner for the fuel jug. So if you weren't familiar, you needed to make a comment, subscribe, and do all the fancy stuff on this video. So we're gonna use our pick a winner here. All right, so pick a winner from this video. You needed to use the word fuel. And there we go. So we've got at EDRUDZKI198, congratulations. You have won the fuel jug from RC Custom 3D Printing. Shoot us an email at thelightersideofrc and we'll organize getting that to you. And just want to give a shout out to everybody who comes on the lives. We have got a live channel if you're not aware of that. It's the Lighter Side of RC After Dark. What the After Dark is live streams here from the shop. One of the coolest things about the live streams that I enjoy is interacting with you guys. So when you're on the live stream, you can ask questions. Everything's happening in real time, usually about an hour long every 2 weeks. As we get into winter, the schedule is very consistent, and definitely encourage you to check it out. It's tons of fun. I enjoy it. Lots of people watch the live stream after as well too, and it's kind of just cool content. And we discuss things that we don't necessarily talk about here on this channel because sometimes it's just the more detailed, finer points. So thank you guys so much for watching. Thank you channel members for supporting the channel, and that's it for this video. We're gonna wrap the Super Bandit up in the next video, starting off with the test runs. Thanks guys for watching this series, and we'll see you in the next video.